Hey, how are you? So, welcome back to this Global Hack Week, to the Gen AI week specifically, and welcome to this stream, which is Rack 101, part 1. And for those who are watching live, you probably remember that some minutes ago we were doing the part 2 of set up your local LLM, right? And in that stream, for the part one and part two, we talked about this. Actually, it's kind of a series of streams that are breakdown in different topics. In the previous stream, of course, the part one and part two of set up your local LLM, we talk about LLMs, right? Silly as it sounds. But hey, it's important that we understand these terms to keep moving on. For example, it doesn't make sense at all explaining RAG if we don't understand the long language model, right? Then when I break up in these chunks of streams, we can say, well, because I'm pretty sure many of you are familiar already with the LLM. So just calling a series or a bunch of streams one way can be, I don't know, not that attractive, I would say. So that's why. uh, and it helps you because if you already were familiar with long language models and how to use them, how to set it up, and you can pass from that information, and you're only interested in this, in retrieve augmented generation, um, well, welcome and thanks for joining. For the ones that are following the series of streams, again, welcome back. You already know that I am Alberto, your male hacking coach from Mexico. And if you're new, you already knew about these previous concepts, and this is your first stream. Thank you so much for joining. Let's start with that then. Uh, Let me prepare my screen to be shared. Actually, let me make my slides. I remember I use, well, remember if you already were in one of my streams. If you're not, if you're, this is your first time watching one of my streams, let me tell you about a great tool I use, which is Marv, that allows me to write my slides for the streams I give in Markdown and then generate them using Marv tool. So give me a second. Okay, I think I have them now. Now, just let me. Okay, that's great. Let me put it here on the main screen. I'm going to share. And okay, yeah, perfect. Let's share now. Right, we are live now. Hello, everyone from Quickers and Cheese. Nice to have you back. Wait, you're Alberto? Haven't you? Yeah, no, I am for. Um, it's an interesting name. Yeah, sure. You must be new. Welcome to Global Hack Week. I woke up from slumber, guys, up with the current Global Hack Week. Well, jokes apart, welcome to this Rack 101 Part 1. Again, my name is Alberto, and well, this is Generative AI Week for the Global Hack Week, right? First, let's check the agenda. What is racked? Racked versus fine tuning, because this is something I want to clarify. And we were doing fine tuning in the previous stream, right? Actually, we didn't have time to complete that. We probably will have time at the end of this. Well, and yeah, at the end of this, why not? And the next part, we will do more racks. Um, some concepts. We're going to check the actual paper where these concepts came from, the workflow, the benefits, implementation example, and next steps and resources. Just let me confirm. Yeah, well, I will see. Uh, I hope this is the last version of my slides. But yeah, what is RAG? Uh, REAG, Retrieval Augmented Generation. It combines our retrieve or vector search with the long language model to ground responses in external data. Why this is important? Well, um, you can remember that actually when we first have chat GPT, when I can say with with plenty confident, that was when the long language models start exploding the world. Like artificial intelligence with that release of ChatGPT with the GPT-3 model, uh, it's where internet go wild and crazy and sorry, I got distracted because I see this. Oh, that kind of rag. What you were thinking of? Yeah, because I know the just the letters don't tell that much, right? Uh, what you were thinking of, or what were your thoughts? Uh, okay, um, yeah, where that was the point where internet go wild about artificial intelligence in general, specifically generative AI, more specifically long language models, and so on, right? So the problem with that what was that ChatGPT used to tell you, hey, I was trained with information until this point on, and I cannot answer you a lot of things for present days. So you couldn't say, hey, ChatGPT, um, it's going to be our sunny day today. No information about that. Uh, in the future, well, in nowadays, you can ask ChatGPT and all the chat interface of the long language models, a lot of things that are actually for the real time, right? Actually, I have a resource here for or GitHub friends that it's great because they tell you how they implement racks on their copilot agent, right? So that's how they use this information to fit the model with the latest information, right? So it, in general terms, it improves the factual accuracy because we are for sure that we are getting the information from fresh resource every time, not only from what the model was trained. It enables the up-to-date knowledge without the full model retraining because else we will be needing to retrain the model every day and that steals its gap of information because in the last 24 hours it can happen a lot and with the retrieval augmented generation we can get that from a database and in this case with vector search, uh, always fresh, always new, right? It also scales by separating the storage from the computer. So once doing the storage and once doing the processing, the actual processing, right? So in very understandable terms, I have to say that that's what retrieval augmented generation is. The fine detail of how this works, well, we are going to get into that. But in the big picture, does it make sense? Please let me know here in comments. Okay, let's continue then. Rack versus fine tuning, because this is another concept that's commonly heard. Let's fine tune, let's adapt to our business needs, right? Um, well, the main difference I would say it's in here, the knowledge update. Because we are going to row by row, but when we are doing this technique, we are adding new documents to the vector store to the database. So every time we're retrieving the information, we get that updated. In a fine tune, we retrain again the model with the new data. It can be done with many techniques: the full retraining, just layer retraining, adding new parameters, modifying actual ways. There are many fine tuning techniques. Um, but that means it requires the retraining, right? So the model changes in Iraq? No, it does not change. It does not change. It just changed the retrieve logic. In the fine tuning, it requires modifying some parameters. It requires modifying even sometimes the weights values. It's required retraining. In simple words. The data source for the RAG, it's, as we already mentioned, the external documents, the vectorized database. In a fine tune, it's the training data set. And these can be very huge. Actually, we commonly heard that the problems of machine learning and artificial intelligence in general, it is that it requires a lot of data to be trained. It was said, I actually don't know, but it was said that GPT was trained with tons of files from internet, right? From some text. Copilot was trained with all the GitHub code base. Imagine hosting that. Imagine trying to retrain that kind of LLM. Well, that's that's insane. I mean, that's impossible for us as users and as simple humans, right? But you can build a rack and you can take that information and add that small layer at the end, which is the retrieval information. The factuality, actually, it's this we were talking about. We use real time data for grounding. In the fine tune one, we may forget old knowledge after retraining, which is also a thing to have in mind. Um, I always put this example, but for example, there are networks that are trained to classify 1,000 images, but you only needed to classify two images, so you can fine tune it to almost forget 998 of them. So you got the idea what I'm talking about? Uh, or you can all just say like, what's the probability of being the other? But what's more likable, these or these ones? Uh, but yeah, there are many techniques. Now, with this in mind, I don't want to say um, fine tune is not right. Fine tune is not good. I don't want to say that at all. I actually want to have in mind that I'm not saying that fine tune it's wrong. I just want to summarize here that, for example, there are cases, there are scenarios, there are um, some reasons why we should apply a retrieval augment generation technique instead of fine tune that. Um, and this makes specifically a lot of sense for long language models. That's why they are long, right? And for fine tune, it can make a lot of more sense for many other types of applications of artificial intelligence. Um, but for this specific scenario, RAC seems to be uh, a really clever solution for having the ability to uh, feed our networks with the latest information. Well, let's move then. Fine tune requires, let's take it this as it is, requires adjusting the model weights, which results in a highly customized model that excels at a specific task. Yes, it's magnificent for specific text. It's a good option for organizations that rely on code-bases reading in specialized language, especially if the language isn't well represented in the model's original trained data. This specific part of the option for organizations that relied on code-bases reading in a specific language is because I took this fragment of text from the GitHub blog I was mentioning. But we can change that for it's a good option for organizations that has data to train the model and wants outstanding performance. Now, then rack on the other hand does not require the weight adjustments. We already say that we do not require to retrain. Instead, it retrieves and gathers information from a variety of data sources to augment a prompt. So it's like adding to the prompt, which results in an AI model generating a more contextual relevant response from the end user. Some concepts here are the embedding model, which converts the text to high-dimensional vectors. The vector store, um, Mongo has one for this, but also it's worth mentioning others like Face, a wave beta retriever, the given query to returns the top key relevant documents, and the LLM generator. In this case, for example, the model we are using to actually generate the response. Um, the workflow consists of making the ingestion, so having the chunk of documents embedded into vectors, then handle the query to get those documents, then construct the prompt and passing like you're an expert. Use the following context. You remember that? Actually, I've seen a ton of hackathons where the projects has these like initial prompt, like imagine you are a software architect developer super professional that has context of all of things, like giving the model a context, but that was like in a static way. But hey, those kids were like completely on the right side, right? And probably if you were watching this and you already applied LLMs or these kind of API, where you can interact with the LLM, like the OpenAI one. At the beginning, this blew my mind because yes, it at the beginning I used to see this a lot. Actually, in my work. Um, when they give us access to the OpenAI, sorry, OpenAI API, one of my colleagues actually created one profile where the instruction, the base structure instruction for the agent was this, like, hey, pretend you're a software architect. So every time I ask you about something, reply with expertise, with patience, with blah blah blah. And I just found that hallucinating. Um, then the generation. So once we have the prompt, we generate it, blah blah, and then construct. Sorry, return the response, and that's it. So the benefits of React, if that's not clear, it's factuality. It leverages of external sources for grounded response. It has modularity. It swaps between models or vector databases without even touching the core model of the long language model. It's very efficient. So it has to offers a lot of knowledge in a very, very light way, thanks to the uh, vector retrieval, right? And the final, it's adaptability. Actually, for this previous one, before I forgot, sorry, I've seen many techniques where not they only. One of the winners of a hackathon I met in Monterey, who they applied. techniques. I select them for winning because they applied vector search in Mongo, not only applying to the document, but they split in chunks. Like, we don't care about the content, or we, for example, as humans, know, like, for example, um, I have to give more context. Sorry, they created like a chatbot for replying for a specific law questions. So they fed the database with articles in the Constitution, and we say, like, for example, for us, article one article can start at Article 1, then Article 2, then Article 3, and so on and so on. But they split in chunks of sizes of data, and they say, like, okay, you are going to look not only for these, but you are going to look for the nearest in the position, and then once you find the one that fit most, um, to give like the how to say that, support of the response, you needed to construct back the full article and then pass it to the user. And I just thought that was amazing. One of the greatest projects I've seen in my life, male hacking coach, I have to admit. And well, this is very efficient, right? You have to admit it. And they didn't even touch the LLM again. Finally, the updatability, because let's say for this example, tomorrow we have another law, or we made a change to Article 3, or whatever. Um, well, we just need to update the database and refresh the vector search, and that's it. Again, we did not touch anything in code. We did not retrain. We did not do anything. So I think that's very scalable also. So great. Before we go to the implementation, let's open those resources I mentioned to you. First is this one from GitHub. This GitHub page, let's make this bigger. Let me share it with you. It's what is retrieval augmented generation, and what does it do for generative AI. So very alike the topic we were covering, right? Um, so one of the hottest topics at the moment, well, here now and 1 year ago, April 4, 2024, one of the hottest topics, yeah, it's now RAG, or retrieval augmented generation. Yeah, explains a lot of what we were talking, why everyone's talking about this. Okay, for example, here, training data has a no cut-off date, difference between RAG and fine-tuning, and how models use context. For example, that's another great. To date, today's generative AI applications are powered by LLMs that are structured as transformers, and all transformers LLM have a context window. Why? Well, we need to revisit again the document, right? The paper from Google. Uh, you will see there why. The amount of data they can accept in a single prop, thought context window are limit size. They can and will continue to grow larger as more powerful models are released. Of course, the input data will vary depend on AI tool capabilities. For instance, when it comes to GitHub Copilot IDE, for example, because they need to talk about GitHub, the input data comprise all of the code in the file that you're currently working on. This is made possible because of our fill in the middle paradigm, which makes GitHub Copilot aware of both the code in your that were before in your cursor, the prefix, and after your cursor, the suffix. Also, process code from other tabs as well as the network tabs, and blah and blah and blah. How this benefits the understanding. Here, for example, we see a chart when they say GitHub Copilot for individuals, like the ones I have, for example. It has data manually provided by the user during the interaction with the AI tool, current file and open tabs, generated text search index repositories knowledge base. This does not. Search index repositories in the internet. This does not. The only one actually that has this is the Copilot Enterprise. For example, the rack and schematic search, unlike the keyword search or Boolean search operators, and ML Power Semantic Search System uses its trained data to understand the relation between your keywords. So rather than view, for example, cats and kittens as independent terms, you go in a keyword search that semantic search the system for that kind of understanding, which is um, why, for example, if you haven't tried it, the Copilot chat in the repositories in GitHub works so well explaining what's in the repository. Um, Rank data source, where drag to schematic search, the vector database, and more information that we can take a look here. It's worth seeing. But also another thing it's worth seeing is this. Oh, give me a second. Okay, I need to make this bigger. Let's start breaking down this paper, right? Uh, Retrieval augmented generation from knowledge intensive NLP tasks. If you don't know what NLP is, natural language processing task, because yes, at the end, that's the field where all the LLMs uh, rely on. Even if they are like multimodal, it's still based off language, right? We need to transfer speech to text, image to text, or vice versa, right? Large pre-trained language models have been shown to store factual knowledge in their parameters and achieve state-of-the-art results when fine-tuned on downstream NLP tasks. However, their ability to access and precisely manipulate knowledge is still limited, and hence, on knowledge intensive tasks, their performance lags behind task specific architectures. Yeah, so we need to go general, that's the main point here, right? Um, Additionally, providing provenance for their decisions and updating their world knowledge remain on open research problems. Pre-trained models with differentiable access mechanisms to explain non-parametric memory have so far been only investigated for extractive downstream downstream tasks. We explore a general purpose fine tuned recipe for retrieval augment generation, RAG. And this is the first time this term was um, actually used. Models which combine pre trained parametric and non parametric memory, it's a pre-trained seek-to-seek model, and then not parametric model, it's a dense vector index of Wikipedia, accessed with a pre-trained neural retriever. We compare two rack formulations, one which conditions on the same retrieval passages across the whole generated sequence, another which we can use different passages per token. We fine tune and evaluate our models on a wide range of knowledge intensive NLP tasks and the set of the state of the art on three open domains QA tasks, outperforming parametric seek-to-seek model and task-specific retrieve and extract architectures. For language generation tasks, we find direct models generate more specific, diverse, factual, and factual language, than a state-of-the-art parametric only seek-to-seek baseline. So they basically are saying here they um, created the right model. They tested against the pre-trained seek-to-seek model and explained how it worked. They put it in comparison and they summarize that they created one one solution that was better, right? That's what I get from this abstract. But let's keep exploring. On the introduction, actually, we're going to go for all the papers. So if you want to have it in your own computer, here's the link. Else, you're going to read with me. So pre-trained neural language models have been shown to learn a substantial amount of in-depth knowledge from data. They can do so without accessing an external memory as a parameterized implicit knowledge base. Why this development is exciting? Such models do have downsides. They cannot easily expand or revise their memory, can't straightforward produce insights into their predictions, and may produce hallucinations. Uh, and I love this part. Have you ever um, experienced that one of these languages, model languages, gives you things that does not exist? Or tells you not true facts. Well, it is not true. It's not a fact. Then sorry, information that's not true. Well, that's the hallucination. Hybrid models that combine parametric memory with not parametric, in example, retrieval-based memories, can address some of these issues because knowledge can be directly revisited and expanded, and access knowledge can be inspected and interpreted. Realm and Borg are two recently introduced models that combine masked language models with differentiable retrievers, have shown promising results but have only explored open domain extractive question answering. Here, we bring hybrid parametric and non parametric memory to the workhorse of NLP. Um, an example, the sequence to sequence model. And let's take a look to this figure. This is the overview of the approach that combines the pre-trained retriever core encoder plus document index with a pre-trained seq-to-seq model generation and fine-tuned end-to-end. Uh, and that's it. For querying X, we use maximum inner product search to find the top key documents, and for final predictions Y, we treat theta as the latent variable and marginalize over sequence to sequence prediction, given different documents. Let's take a look then to the image. So we have the input, the divine comedy, Jeopardy question, generation, and the answer question. We have the encoder, we have the retriever that's actually using the maximum inner product search MIPS to find document that it's more likely to answer that question. Then we fit this with the generator. Well, we don't, they do. Sorry. And they fit with the top K documents degenerated with the parametric for making the output. So this is the 14th century work. It's divided into three sections, Inferno, blah, blah, blah. This is the question generator. So we have fact verification label. that says, okay, where you get this, how we know this is true. And in the middle, ear includes the type, the tympanic cavity, and the three occyles. Define the middle ear, then the question, and something about Barack Obama was born in Hawaii. I don't know why. Verification fact query, I'm guessing. Okay, yeah, I'm guessing, yeah. Um, for example, question answering. Yeah, sorry, I understand better now after it's like that. So one case can be question answering. So we have define middle ear. We pass the query to the retriever. We check for documents. We feed the documents to the generator, which is the LM. Well, for now uses, and we get it. The middle ear includes the tympanic cavity and the three occyles. Another um, Another example of usage can be a fact verification. So we make a fact query. Barack Obama was born in Hawaii. Let's see if that's true. The answer it's supports. I don't know why, but yeah, the fact verification it helps us for saying label generation. Uh, the divine comedy, we can say Jeopardy question, generate a question about the divine comedy. That's another use case they tested this on. In the same process, we encode the input. We use the maximum inner product search for retrieving the documents that make sense for that. We feed that to the generator, and the output is a Jeopardy question. Um, so let's continue. We enter pre-trained parametric memory generation models with a non-parametric memory through a general purpose fine-tuning approach, which we refer to as a retrieval augmented generation, RAG. We build RAG models where the parametric memory is a pre-trained seek-to-seek transformer, and the non-parametric memory it's a dense vectors index of Wikipedia, accessed with a pre-trained neural retriever. We combine these components in a probabilistic model trained end to end, which is the figure one. The retriever, dense passage retriever, hence Crawford DPR, provides latent document confined, uh, conditioned to the input and the seek-to-seek model, in this case BART, then conditions on these latent documents together with the input to generate the output. We marginalize the latent document with a top key approximation, either on a pure output basis, assuming the same document is responsible for all the tokens, or a per token basis. So maybe this is kind of too dense to digest for the moment. Uh, Pre-digested one, I can say to you, it's keep up with the image. The point here, or the main idea, it's the tested on not only using the generator, but the end-to-end um, instruction of encoding the query, generating the or getting the retriever to use the document, and with that feed the parametric generator. And well, let's move then. Methods. We explore RAC model, which uses this input sequence to retrieve text document and then uses as a conditional context when giving the target sequence, as in shown figure 1. Our model leverages two components, the retriever with the parameters that returns the distributions over the passages, giving a query queue and a generator parametricized. So sorry, by Omega, that generates a current token based on a context on the previous I minus one token, the original input and the retrieve passage. To train, retrieve, and generate. Okay, I think we can skip this for a moment and let me see what else it's worth seeing more than the actual mathematical explanation. Um, okay, for example, more than the sequence model and the token, the retriever, the thing we mentioned before, and the generator, let's talk about the training. We join the trained retriever and generator components without any direct supervision. That document should be retrained. No. Decoding at the test time, rack sequence, and rack token requires different ways to approximate the argument. Yeah. Some of the experiments they conducted, the open domain question to answer, the abstract question answering, Jeopardy question generation, the fact verification, that's the one thing we were mentioning, and the results. So the table one showed the results for ranked along the state of the art models that were actual um, fine tuned for their tasks. So, for example, closed book, open book, uh, um, table 2, narration and classification test course. MS Marcus thought A is fever is and fever 2 use gold context evidence based model without gold access online. Okay, so the two options rack token and rack sequence. Abstractive answering Japan generation. Well, yes, fact verification. This is for NLP answerings. The confusion chart for two additional resorts. Index hub swapping. I want to see what they um, say about the results related work. Single task retrieval. Prior work has shown that retrieval improves performance across a variety of NLP tasks when considered in isolation, such as include open domain question answering, general purpose architecture for NLP. Well, one of the things I have to say, for example, about the well, I want to talk to you directly. So um, at this point, I want one thing that's my personal opinion that I want to say. It's that the problem starts when they referred and they mentioned that in the beginning the I am going to quote because it's important. Large pre-trained language models have been shown to store factual knowledge in their parameters. Now, remember, these are artificial neural networks, and these are kind of what we expect to be neural networks. Uh, and in your mind, I'm not sure about where we store the data. Of course, we don't have a um, separate database, right? Of course, here we do have to store our information in our neural networks. I will say I'm no neuroscientific. I don't know. But for the moment, it makes a lot of sense that we in engineering separate these tasks as one thing should be knowing the language, for example, English, Spanish, a lot of things. But if you ask me, for example, Alberto, what's the capital of I don't know. Japan. Of course, I know. Like, sorry. Of course, I know that Tokyo is the capital of Japan. But if you ask me for a different one that could be more difficult, I will say I don't know. I don't know, but I know where I can look for it. I know where I can um, find that information, and I know I can get that information because let's say there is in a book, and I know how to read English, and I know what based on the context what I'm looking for. So at some point, I will say I would like to think of these models as models that should know how to do natural language processing. That, of course, I'm not talking about the long language models because that's the idea of the long language models. The to store the information in the parameters, right? But for I think we could efficient the process of NLP, um, giving models that just know no information but no context, but know uh, how to speak something, and then feed them or give it the ability to look for information in a database, or for us as humans will could be that internet, books, I don't know, many places we can find information, right? uh, Chats, etc. TikTok, YouTube, a lot of things. So I think that's something to have in mind. I will say that we can start interesting conversations of what not only in paper it's happening, but how we can figure other alternatives to do artificial intelligence these kind of ways. Um, of course, my NLP it's not my department, but I was just wondering when I was studying these kind of things, like why, and that question popped to my mind. Like, of course, we as human have to have at some point in our neural networks. Um, the information, right? Which I find fascinating. At the end, one hard disk or any type of memory we developed in digital computing, it's just bytes of information, ones and zeros. So I don't know how we could translate that to neurons, to say like some connections are in their parameters, how I'm supposed to know my name, how it's supposed to know my, um, I don't know, like my mom's name, and that kind of information. I just find it fascinating. But also, I'm wondering if it's possible to have like a empty neural network, empty of all knowledge that's not related to the language. I once heard that there are specific parts of the brain that works for that kind of informations, right? So I don't know if that's another possibility, like combining different neural networks or different parts of a network that just one knows how to speak a language, for example, or has related to language, neural language, natural language. Another one that has the information that has embedded the parameters in it. Uh, that just touched me. So let's continue. Mm, yeah. And okay, I wanted to get to the results related work. We were here discussion. In this work, we present hybrid generation models with access to parametric and non-parametric memory. We showed that our RAG model obtained state-of-the-art results on up domain QA, And we found that people preferred rack generation over purely parametric BART, finding rack more factual and specific. Um, we conduct and truth investigation of the learned retrieval component, validating its effectiveness, and we illustrate how the retrieval index can be hot swapped to update the model without requiring any retraining. In the future work, it may be fruitful to investigate if the two components can be jointly pre-trained from scratch, either with a denoising objective similar to BART or some another objective, or work opens up new research directions on how parametric and not parametric memories interact and how to most effectively combine them, showing promises in being applied to wide variety of natural language processing tasks. Uh, Broader impact, these works offer several positive societal benefits over previous work. The fact that it's more strongly grounded in real factual knowledge, in this case Wikipedia, make it hallucinate less with generations that are more factual, and offers more control and interoperability. RACT could be employed in a wide variety of scenarios with direct benefit to the society, for example, by endowing it with medical index and asking it open domain questions on that topic, or by helping people be more effective at their jobs, which I kind of think it's the more frequently used right now. It helps me a lot, uh, even though you are not saying it. You probably are using and seeing the impact of this work in your current life. With these advantages, we also count potential downsides. For example, Wikipedia or any potential external knowledge source will be never entirely factual, and well, that was a known problem since many time ago, right? And completely devoid of bias. Since RAG can be employed as a language model, similar concerns as for the GPT-2 model are valid here, although arguably to a lesser extent, including that it might be used to generate a buzz, faked or misleading content in the news or on social media, uh, to impersonate others, for example, or to automate the production of spam phishing and context. Actually, I was in an interview before before the session, and I was talking to the person, and I was saying like, yeah, I'm going to give a session about generative AI later today, and he told me like, oh, don't do that. We have enough fake news at the moment, and I was like, okay, yeah, I get the point, but they are not going to make fake news, are you? Well. Um, the point here is that, of course, these downsides and the challenges of the work, it's that it's a great tool that can be used for great and for bad, right? So it's important to make these kind of statements. In order to mitigate risk, AI systems could be employed to fight against misleading content and automated spam and phishing. So the acknowledgments for this goes to, of course, how many faces mentioned and a lot of other people. And these are the references. So again, this was amazing, and you probably again can't relate that much as you are doing to ChatGPT and stuff, but this is being implemented by the systems you're using probably now in your day by day. Um, so now, now, we can return here, and well, the implementation example. I don't think we should have enough time to do the implementation right now. Um, on the other hand, we have missing the finish of the fine tuning for the previous session. So I will tell you what. We take the overview of what drag is. We do great job understanding it and comparing it to fine tune. So I think it's appropriate enough that we finish or fine tune this session, and then in part two we dedicate all the time to implementing rack, right? Because it's not quite a complicated task, but we require time. So let's let's do that. Let's go to the also. I think I didn't give the repo for this, but it's github.com/alberto/first and well, uh, I'm not finishing the session right now. I will share this at the end, but you will see that you can find the feedback link also. Uh, so let's go. Code. Where was local? LLM. Let's finish our tuning. So we were at the point where we needed, or we had the problem that we need to download the Hugging Face CLI and um, how to say it, authenticate ourselves, right? So let's do that. I probably haven't do that, so let's go to Hugging Face. Let's open that Hugging Face. The AI community, explore apps, browse 1 million models, deep side sheets, Spark 3D, all the models, data sets, the home of machine learning. I want to sign up, login. I'm not sure if I have an account. Let's try it with. Oh no, yeah, I for sure don't have an account. I'll do this hands off stage for privacy, but give me a second. I need to confirm that I'm a human, so I need to select bats. Okay. Sorry for the silence. I was focusing on creating this. Um, and I found, for example, here in profile, you will see that there's a great model that generates emojis better than the Apple ones, and I select as my avatar Obi-Wan with a Mexican sombrero, uh, and this was the result. So amazing. Let's let's return. So, engineers, small agents, awesome AI agents, heavy spaces, open source libraries, that studio, the robot, building smart robot in your garage, model train, dedicate endpoints, maybe this model train and share tasks, or some task available. Please check. Okay, I need to check for my email. Give me a second to validate. Okay, now I'll refresh. Okay, perfect. Uh, okay, I will check for the models and I will check for the train. And here I have the models. I wanted to hammer 3. 1 billion parameters. Yes, I'm guessing yes. Acknowledge license. Okay, I authorize this. Okay, and usage. Sure. I just want to have access to this. So I was looking for something like CLI or something like that. So let me see to the docs. Transformers, reinforcement learning. Oh, what? TRL? Well, still interesting, but hey, I wanted a fully open reproduction of DeepSeek R1. Okay, documentation, how Python library, interface, yes, deployment interface, core LM and libraries. Yeah, let's try to run it again to see the output because uh, source activate local Python train. No, sorry. Um, what was the name? Fine tune model. And it says the error you're encountering means the Google Gem it's a gate model. Okay, cannot access gate repo. Authenticate your environment. You'll need to go to the mods page and make sure you log into your Fireface account. You can authenticate. This command will give you. Is there a way we can do it without CLI? Yes, you can authenticate grammatically when passing your face access to the. Okay, I should get my access token then. Profile settings. Access tokens. Here it is. I don't have an access token, so I'll create one. Fine grained. Well, I create one temp global Hagwick. Read access to the contents of all repos. Read at least read permissions. Okay, well, let's create that token. Let's copy it and let's stop. And now I need the Hugging Face token. Nice. Two. And here, where's the problem? Okay. Let's see if that was the problem. Okay, seems to be working now. Perfect. We have another problem now, but okay, let's inspect. During handling, there's another exception. Pre-trained model name or bad from pre-trained. The package metadata was for. Okay, let's take a look at this. No, I don't think that will solve it. Okay, let's do another thing. That's we recently closed notebook of having that. Uh, uh, I don't know. I think the Hugging Face. Notebook PE. No, what was the name? Lord. Well, we have the name here. PFT. So PEFT Hugging Face. And here we found the link to the notebook. Casual lingual modeling. Delora. Yeah, we were checking this. So, model name. Let's hide this and this and hide this with this. Okay, okay. Well, um, give me 1 minute. I need to grab more water. And in the meantime, um, let's try to run this to see what's happening. Be back. Great. Now I'm back, and I think just in time, um, because the output it's actually what we expected. We print the model trainable parameters. The new embeddings will be initialized from a multiple blah blah blah. Trainable parameters are less than the billion we have. We have the model for 1 billion parameters. This is less than 0.07%, 75 to if we round it. Uh, Still, great number of parameters to train, but I think we can do it. One last thing I want to check is that here for applying LoRa, the LoRa config here. Okay, no, well, we already tried this. We have perfect the model print and the model trainable. We need to prepare that sets. That's the interesting thing. Uh, we are not going to train it with a lot of information. Actually, I created a fact.json that has questions for Global Hack Week, for example, where I can find the schedule. Hey, you can find the schedule on globalhackweek.mlh.io. Hey, what's Global Hack Week? Hey, Global Hack Week, it's a virtual week-long series of streams organized by the mainly hacking, where participants can learn new skills, build projects, and connect with community. I didn't create this. Actually, I asked Gemini to create many of these. But hey, we are going to train our model with this. I just want to make sure of the format because, for example, here it loaded the data set, it split it, it got the context column, the label column, and the max length of this process functions, batch size, targets, model inputs, tokenizers, and we kind of don't have that. We import data set from data facts. We split it into a train, its type of JSON. Then we return the tokenizers with the prompt, which I think I should change here because I have that for user. Uh, then the map of the tokenizer. Then we trained it and we save it. So I'm guessing I should make some changes here. Yeah, probably. Yeah, check them a lot of this sample from evaluation dataset. Well, what I'm going to do is that take a look to my code and format this JSON gfact JSON into what is expected to train the model. And well, let's wait for that. Also, you're not commenting a lot this afternoon. What's happening? Um, you want me to explain anything else? Did you miss? Everything's clear? I don't know. But please let me know here in comments. Hmm. It's taking its time, so we can relax. What I'm thinking is that the problem might be based on what's happening here. We should have a context. Well, not specifically a context, but two columns, one for user and assistant. Okay, I've looked at your fine-tune model.py script and your facts file. Your fine-tune script expects the datasets to provide examples record when each example has a name prompt. The context of X prompt is the tokenized for fine-tune as instruction modeling like HEMA. This prompt field should contain the full conversation turn, including both the user's query and the assistant's expected response format, according to the model's chat template. Uh-huh, uh-huh. Here's how you can transform your facts into the expert former. Can't you format it? Simpler, isn't it? Yeah, I think that's okay. I can't. Yeah, format the fact, format the JSON to be what the fine fine tune file expects. Okay, good enough. Now is it everything right on the fine tune model dot py? Pretty clear so far. Thanks. Hey, thank you so much, Professor Professor Dianic. I think it's Dianic. Okay, thank you. Um, the fine-tuning model script looks mostly okay for fine-tuning, but there are a few important points to consider based on the current state of the command outlines. Yeah, I'm going to delete this. I think this is for past integration. Uh, Quantization. Yeah, no, I don't want that. Device map now. Token biddings. Yep. This line resides the model token and biddings layer. It's typically only necessary if you have blah blah. Let's set path you're using. Not sure. Yeah. You already know the JSON correct in file to train. Come on. I am trying to use as much AI validating human responses. Yeah. Yeah, I get it. Actually, this is just me being lazy. I have to admit it. The real use case in this scenario will be like, okay, I don't know, a whole department. The marketing department should give you, hey, we investigated, we did our job, and now this is the commonly frequent asked question, right? And this is how we want to respond. And that you, as the engineer, the developer, you should be only implementing the database. Of course, that should be the best thing, but in practice, of course, you need to gather and collect the data. So, yeah, now I know why this is funny. D for down, New York for the city. Oh, yes. Sorry, I didn't read it that way. So, Professor D, New York. That's great. So, I've reviewed it, blah, blah. Correct formatted for each having prompt. Okay, it is. Okay, yeah. Here are the adjustments to make more robust. Enable. No, I don't want that. Token. Okay, this actually is something I want that. Um, oh yeah, I have it already, of course. um, Config Laura pre-train model trainable parameters. The data set. Yeah, split comp prompt trunks max length padding. Add padding. Well, I believe you. No, I don't believe you. These maps no clear per evidence num epochs tree login steps save total limit train model. Okay. 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 Let's try to run this fully to see or how many times it takes. I hope not that much, and I hope this actually runs as we want to. And in the meantime, well, okay, uh, we have something happening here. The new embedding will be initialized. Okay, we have our print gathering this train split. It's happening. Perfect. And we have a problem. Okay. User warning. Ping warning argument set as true but not support on MPS now. Then the bot. Okay. Okay. The label. Let's complete. Give this to Gemini. And in the meantime, let's back to what's happening here. PFT model, since PFT hides base models input argument, if labels it's not giving, labels can set automatically within trainer. And trainer was this, arcs are this. Model it's okay. That said, I'm not that sure. And the arcs for me looks valid, but it says label names is not giving. No label names provided for model class. These errors typically occurs during batching when subsequents have different lengths and they haven't been uniformly paddled or truncate the warning. Not label names also suggest that the trainer isn't sure how to handle labels. Okay. Uh, well, yeah, probably then you were right about that. But, well, yeah, let's try it again. Data collator for language model tasking. It's best to use that this collator. Where's that use? The tone. Okay, one data collator and where the data. Okay, okay. If that doesn't work, then I can try with this. It looks legit. Let's see if we have the same problem. Okay, it changed now with the padding. It's strongly recommended to train HEMA tree models with the eager attention implementation instead of SDPA. Use eager with ATN implementation, but it haven't changed. So, sorry, it haven't failed. So I'm guessing we're doing it right. Performance warning. Interesting. I would say what. Uh, Sorry, this is getting too slow right now. I'm guessing it's making the computation, so that's why this is getting too slow. Um, no, I am okay. Can you see me now? Okay. Okay. I think I freezed for a moment, but I think you can see me and hear me now, right? I'm sorry. I think it was just too much computational effort. Uh, but yes, I see we have more problems here. It's strongly recommend to train. Okay, that's recommendation, but this is an error. Traceback, train. The model did not return a loss from the inputs, only the following keys. Logits for reference. The inputs resume are inputs ID attention mask. Okay, let's give this to Gemini, which supposed to be much more better and efficient than HEMA, right? Um, Eager attention implementation instead of SDPA. Laura dropout. Okay, the value model did not return a loss only following King's means trainer. It's expecting the model to output a loss value during the feed forward pass, but it's only receiving logits. This actually happens because the model isn't being provided with labels to compute the loss against. For casting models, okay, here's a temp implementation when loading the model. Okay, makes sense. That's the recommendation they give us. Uh-huh. From pre-trained, eager, casual, pre-trained, ATM. Okay, what else? Set tokenizer. Okay, well, here it is. Load tokenizer. This tokenizer. It's okay. If tokenizer path token is none, then tokenizer is token. In the LoRa config target model, the drop task type casual LML. In here, the difference for the LoRa config it's target models. LoRa dropout, alpha. There is no bias and no casual. I'm not sure. Okay, the dataset return the truncation max length and the padding. DS map remove columns prompt on the data layer. Why not? model train args and the data collator. Then train and save it. Okay, I think that will be our last try since we run out of time. Well, before we run out of time, I hope to see. But yes, hope this built fine. And remember, for the next part tomorrow, we will do kind of the same, but without retraining, without this huge mass doing with rack, right? Okay, again, probably my computer is going to freeze. I don't know if I am going to lose you first couple of seconds, but we will be back with the results. So far, so good. So far, so good. Come on, no warnings this time. And oh, I see we have a Laura to folder, but of course it's empty. I'm starting to see that the cursor it's kind of slow, so probably we are going through the complex process. And let's wait to be optimal. Am I back? Hey, I just want to confirm. Okay, I think I'm back. Um, yeah, I'm seeing that I'm in the stream. Okay. Oh my god, we still have some errors. Okay, okay. Train. Yeah, again in train, but these are different. MPS backing out of memory. Oh, MPS allocated 15 dots. Yeah, almost 16 gigabytes. Other allocations max allowed were 18. Try to allocate 2 on private pool. Okay, we run out of memory. I was worrying about that actually. Uh, you know what? Again, let me talk straightforward to you. Well, we did our best. We tried, and it was fun. I warned you on part two of the previous session of the setup your local LM that this kind of retraining, even with the BEFT, was not a piece of cake. So that's quite important, and this is the main importance of retrieval augmented the systems, right? You may see it because even that we are only manipulating what was it 0.7, yeah, less than 1% of the 1 billion parameters this small between codes large model has. It's still 745,000, yeah, 472 parameters, and that's big. So my computer can handle it for the moment. I'm sure that if I run more scripting and I modify some data, I will be able to, but for the moment I don't. So, plus, we're run out of time. Thank you so much for joining. Stay tuned for tomorrow. We will be checking part two. And now, before I forget, yes, go to, let me add this to stage. Go to the repo to find slides. Tomorrow you will find the whole code for what we do, for what we are going to do, and the feedback link. It's very important. Please share your thoughts with us. We will appreciate a lot of all the comments, no matter if you think we could improve some things. Always feedback. It's welcome. I see just to end that I have some comments. What is the project about, rack or fine tune? This one, it's rack. Sorry, this one was fine tuning. Tomorrow we'll be doing the rack. You can see better the difference and why rack it's important, right? Yes, this was a good try. Yeah, thank you so much. I think code right now it's kind of uh, decent, but the point here was the limitation for the hardware. So you can try to run it in your computers, and that's it. Thank you. Hey, no, thank you so much. I really appreciate you spend the time being here. It was my pleasure, and I hope to see you tomorrow. Thank you so much. Bye.